Hello, this is Group5. Our topic is bakery sales predictions. We have Annie, Queen, Waiting, and me, Yingyi. So welcome to the presentation of on the analysis of daily sales data from a charming French bakery. In this presentation, we decided to disclosure some details of the data sets that offers a comprehensive snapshots of the bakery customer transactions spanning from January 1st, 2021 to September 30th, 2022. With a focus on uncovering patterns and insights, we aim to provide a better understanding of the bakery performance and its transaction with customers over this period. So let's discuss a little about French bakery history. French baking tradition traces back to Middle Age, where bakers refined their craft to create and arrange bread varieties and becoming an integral to French society. Later on, it has a strong influence on global cuisine. Our data sets comprise a substantial collection of 234,000 entries, capturing the essence over 136,000 unique customer transactions. These transactions are spread across 6 informative columns that encapsulate crucial aspects of each sales. And as we embark on this journey, we're going to explore these columns to extract meaningful insight and drive actionable recommendation for bakery future vendors. So if you look at the left-hand side picture here, this is our raw data. And on the middle here is our transform data. Our first step is we break down time column and turn it into date times. And daytime will be will have like 3 different categories. One is the morning time, afternoon time, and then we also have evening time. Okay, so the second step, we bucket hours based on time column. So for example, if someone entered the store around like 8:30, we will bucket that person into the A section, 8 a.m. sections, and then the third step with that is we break down day column into weekday, date, month, year, and quarter columns. Very similar for the last step, we turn dates column into calendar quarters. So the third step and the fourth step are basically trying to provide like some trend analysis using these transform data columns. Here's a picture of the best-selling menu items. Number 1 is the traditional baguettes, and then it has 118,000, about that number. And then the second one is Alcazon. We have like the third one, etc. In the next slides, we're gonna discuss a little about our literature review. So throughout the 3 papers that we look into, we identify the most frequent model that is being used is the logistic regression and also the zero-inflated Poisson models. So this is our approach to start our analysis. And next, Annie will discuss about some of the linear method that we use.
Thank you, Yingyi. And as Yingyi mentioned, from the literature review we performed, we discovered that the Poisson regression is a commonly used method for modeling and predicting data involving counts. At the same time, we observed that high right skewness exists in our data, where large count events are relatively rare. Thus, we decided to start analysis by utilizing the Poisson regression model, which also provides easily interpretable results with coefficients that directly represent log of counts for each unit change in the predictor variables. After fitting a Poisson regression to our data, we made the following observations. First, we see that there is seasonality present in the coefficients of the predictors. This information can be very helpful for bakery owners to manage supplies and inventory. However, by further evaluating the model assumptions, although there is no zero inflation present in our data, we observed high overdispersion with a Pearson statistic of 6.23. This means we do not satisfy the assumption of the Poisson regression model. In order to better model the data, we then proceeded to explore the negative binomial regression, which is a more general case of the Poisson regression model. The negative binomial model allows for the variance to exceed the mean, which means overdispersion can be taken care of. And from the results, we observed that the summer months are the most popular months for the bakery, with the morning being the busiest. Interestingly, we also see that for some of the unpopular products, an additional unit sold negatively impacts the counts. Overall, the results of the negative binomial model yields a R-squared of 0.76 and an RMSE of 17.3. From the residuals, we see that the predictors are generally lower than the actual units sold, with the exception of being the morning. This is actually a desired result because then the bakery can slightly overstock in the morning while continuously lowering leftover inventory with lower prediction than actual for the afternoon and the evening. The only point that is a little concerning for this model is that the RMSE is a little bit higher than desired. Thus, we wanted to explore other methods to model the data as well. Next, I'll pass it to Wei Ting to explain some of the nonlinear methods we tried.
Thanks, Annie. Now let's talk about other methods we use. So we're using a method called regression tree, which create a role model decision based on our data feature to make the prediction. It's like making the breakdown of the problem into a smaller step that help us predict outcome accurately. So the reason we're choosing this model is the model has a small element picking the importance feature for the prediction. It's especially helpful when features are not straightforward. It even handles case when things are even straight lines. So it's great for when dealing to categorical outcomes and like a yes or no answer. So the bakery case will be beneficial for that. Another point is easy to understand. So the model is simple to understand and to explain. The decision to use those sets are easy to follow, and we can see and explain the trains easily. We can even visualize those rules by finding out a feature matters the most and plotting into the tree. So fine-tuning for the best result we're trying to cross-validation for the best ability to calculate the decision tree without losing the accuracy. Another way is trimming the branches of the tree so it fit just right for the prediction. After that, we should see the result for the RMSE is 8.54 and R square is 8.83, and that's where another method we're talking about is random forests. So that is a decision tree that we can work on to give a better prediction. It's like a combination of the different model for more accurate. See, when we're getting higher accuracy by combining the prediction for a tree, you will smooth out any mistake that a single tree might have. And you can see by the number of tree we increase, and the result will be better by the peak at almost 30 or 25 point a tree. So handling that tricky situation is the reason we want is because the noisy data and the strange value that can throw off the track, so we need to reliable source to make it sort out. What matters for the feature is that most of the prediction are figuring out the best result for using the cross-validation. So figure out how many tree we should have in the random forest is like finding the right numbers of player for the correct prediction. So after that, we can find out the perfect number of tree for random forests, giving accuracy and robust prediction. What we found by digging into the analysis that we discussed what part matters most of the prediction is the people by more baker product in the morning. This is impacting the sales a lot. So we saw an interesting trend based on the sale going to the weekends and during July and August. Tell us the different time that can influence what people buys and understanding the key factor that can help us understand a better decision and making a market strategy for the owner. We know what drive the sales and equip the better marketing choice for the business. Now we pass to Quinn to talk about the conclusion. Thank you.
Okay, thank you, VT. Now let's look at the conclusion of our project. For this project, we have gone through 4 different the model and the random forest, regression tree, Poisson regression, and negative binomial. And clearly, based on the RMSE, that root mean square error and R square value, we picked a random forest because this model, it has the smallest RMSE and the largest R square. So we think even though this model takes the most computational resources, but compared to Poisson regression, that dropped 50% of RMSE. So this is our best model, random forest. And by leveraging historical sales data, we have achieved a robust model that can aid in inventory management and the production planning. The implementation of this predictive module will enable the bakery owner to optimize its resource allocation. By aligning production with predicted demanding, the bakery can reduce waste, control the cost, and ensure the products available when customers want them. So here, based on our model, we predicted for every day of this month, from Monday through Sunday. Clearly, we can see from this page, during the Sunday, we needed the most the products available, and for each individual day, we need more in the morning compared to the afternoon and the evening. So, and then we give specific numbers for every single day and for each section of the time. And also, for each day, we can predict the specific product. And clearly, we can see most of the times that traditional baguette, they need they're the favorite the product, so we need to make sure we will meet the customer demanding for that. So that's how our model will help the bakery owner to running their operation efficiently. And it's crucial to recognize this continuous improvement is necessary. We should continuously bring the new data and refining these models parameters, so that will ensure to kind of predict the product needed and then to capture the customers demanding. Okay, that's our presentation. Thank you for your time, and any questions?